Hello everyone, today I will be showing you how to install Kratix on EKS, how to register and configure a Kratix worker cluster that's also running on EKS, and then we will learn about some basics on how to create and use a promise. I'll be following the Kratix installation guide and using some ready-to-use examples that we have for AWS EKS. Link to this Kratix example repo, also link to the Kratix installation documentation, can be found in video description. Make sure to check them out after finishing this video. I already created some EKS cluster that we will be using for this demo. So the first step for us preparing our Kratix platform cluster is to install Cert-manager. Cert-manager is a certificate management tool. Kratix relies on Cert-manager to issue certificates for its webhooks. So I have already used AWS CLI to fetch credentials for my EKS cluster. If you haven't done it, you can take a look of the AWS CLI documentation to see how to do that. Yeah, so the Cert-manager pods are running. And by the way, I'm using K, and this is the alias that I have locally for kubectl. So with Cert-manager being already being installed, we can then move on to install Kratix. So this command is just going to install Kratix for us, is installing Kratix by using the all-in-one Kratix release manifest. You can find the Kratix release in syntasso/Kratix GitHub repo. Let's come back to the terminal, and we're gonna install Kratix now. Some installation error, and I think this is just because maybe Cert-manager is not completely ready yet. Let's just reapply. Yeah, everything went through the second try. So with Kratix being already being installed, we can move on to the next step. Next step is to set up state store. So state store is the place that Kratix would write documents to. Kratix supports both bucket state store and Git state store. Since we're using EKS, we're on AWS this time, let's use S3 bucket as our state store. I have already created a S3 bucket, quick start AWS. As you can see, this bucket is empty. It doesn't have any objects in it. Let's take a look of my bucket state store definition. Bucket name is quick start AWS, like we saw in my AWS console. I'm giving it as endpoint. Also, you need to give it a Kubernetes secret that has AWS credentials that have read and write access to the bucket. Yeah, with our bucket state store created, next step would be registering a destination in our platform cluster. This is the destination definition. It's referring to the state store that we have just created above. So that's everything we need to do for our platform cluster. Next step will be setting up the worker cluster. For that, we need to install Flux. Flux is a GitOps tool. You can also use other tools that you already have in place, like Argo CD, whatever ones that you prefer. we're going to use Flux for this demo. So to install Flux, let's copy the command. I'm also going to change the Kubernetes cluster that I'm targeting here. So we see Flux system namespace being created. And their pods are running. So now we need to configure Flux to use the same state store that we created earlier. For that, we need to create a Flux bucket resource and some Flux customization rules. So this is the Flux bucket definition I have. It's referring to that same S3 bucket quick start AWS. We also need to give it a Kubernetes secret reference that contains AWS credentials. After the bucket resource is created, we can create some Flux customization. So we have two customization rules, one for the subdirectory resource, the other one for the subdirectory dependencies. And if you remember, worker is the name of the destination that we created in our Kratix platform cluster. So Kratix also creates some canary resources when you register a state store with it. So now if we take a look at our S3 bucket and hit refresh, we see a worker subdirectory being created and a dependency and resources. Under dependency, we have a canary namespace. Under resource, we should have a canary config map. So because we have Flux installed and also have Flux configured correctly, we should see these canary resources already being reconciled by Flux. So if we do a get namespace, yeah, we have a Kratix worker system namespace there. This is the canary namespace. And let's check our canary config map. The canary config map is going to be created in Kratix worker system namespace. Yeah, so we see a Kratix config map here. So that's everything we need to do to install Kratix. After all of these steps, you now have a Kratix platform cluster and a worker cluster, and we have everything wired up between them. So now it's time to create some promises. Promise I will be using for this demo is in Kratix example under quick start install AWS EKS. So this is a simple SQL promise that's going to give us a AWS RDS. Go back to my terminal and here's the same promise. So this promise also requires a Kubernetes secret and which should contain AWS credentials that have access to create RDS instance. Let's switch back to target the platform cluster. And first, let's create that AWS secret. And now let's create a promise. Yeah, so the promise is available. We can now create a resource request. So this is our resource request. We're going to have the request called example, and the size of the database is going to be micro, and the engine will be MySQL. If we go back to the promise definition that we were just looking at, you can see that under workflow, we have resource configure workflow defined, and we also have a delete workflow defined. So because we have just requested this particular resource, that resource configure workflow is going to be started, which means now if we do a k-get-works, so that workflow has been started, and this is going to take some time because provisioning RDS is going to take some time. We can look at the log from this work. Oh, looks like everything has finished. So if we go back to our AWS account and hit refresh, that's our RDS instance. So you can see that it's called example, like the name that we have given it for our resource request, and the size of the database is macro, and the engine is MySQL as we have configured. So to recap, we have installed Kratix on EKS. We have also registered and configured a Kratix worker cluster. We have also used a simple AWS SQL promise. Here are some links that you may find useful. So the docs I followed, that installation doc that you saw earlier, is in Kratix docs. The AWS SQL promise that I use is in Kratix example. And if you want to look at some more example promises, you can check them out in Kratix Marketplace. That is everything. Thank you for your time.